Can you see that these two sticks are in line? The red nearer to me, further from you, and this blue nearer to you. They are in line, right? Are they in line? No, you see with one eye closed at this. Yeah? Are they in line?
No.
Wow, almost. Almost. Are they in line? You adjust yourself, yeah. Are they in line? They are both vertical, right? Okay?
About that.
Okay. So what I'm going to do is I'm going to use this to hit this portion. Okay? Now, let's see, I hit this portion. And this without stand rod is going to expand. And when it expands, oh, wait. Bale. Should be like that, yeah. Okay, this should be both in line. So now I will hit it to expand, okay? Hit. Careful, huh? Hit. Maybe I take another one. I take another one. What do you notice about the reed stick? The rod which is resting on the straw is going to rotate the straw as it expands.
Oh yeah.
Huh? And when you rotate the straw, the red pointer turns from our direction anti-clockwise. Can you see?
Yeah.
Now it is, hold it there. Now it is turning. Can you see it's turning?
Yeah.
Yeah? Can you see that turning?
Yeah.
Now you hit some more, you will turn some more. Oh, now it turns a lot more. Can you see? Yes. Can you see?
Yeah.
Yeah. Let's see how much it will turn. Now the turning is very visible. You close one eye, you should be able to see it everywhere. Huh?
Yeah.
Yeah. That is one experiment that most physics books, the better ones, will show you the expansion of a solid. Otherwise, it's very difficult to show expansion of a solid. Huh? There you are. Yay! Can you see it's turning?
Yeah.
Yeah. Turning by quite a lot, by using a pointer. Now, in railway, they have got to make gaps in the railway for the iron railway. Otherwise, when it's hot during a drought, the railway will walk. So because of the gap between the rails, that's why the train wheel tends to go as it goes, the wheel goes over the gap. You know? Yeah. So there you are. There you are. Yes. So now we can see that this has already moved. Huh? The red has already moved towards the right, because as the expanded bar goes over the straw will rotate, and as you rotate a little bit, this will magnify the amount of rotation. Huh? And the rotation of this straw is due to the expansion of this heated rod. Yeah. Yeah. I have written this book since 1988 and I've never performed this experiment. And now we're doing it in 360 degrees VR. Okay? Of course, we can put it at the YouTube. Then you can see it in VR. Now, again, to show the expansion of solid, this is another one you can show the expansion of solid. Now, of course, this one, when it cools, it will come back to be parallel again, one behind the other. Now, this is called, what is this? This is called, it's not in my book, or it's in the book, but it's called a bimetallic strip. This side is iron, and this side is brass. And you know iron, I-R-O-N, iron, 4 letters, right? Brass, how many letters?
5.
5. So when this is heated, this brass will expand more than iron. And this is called a bimetallic strip. So what we are going to do now is, this is almost vertical like that. Okay? So what we are going to do now is we are going to heat this. Okay? We're going to heat this. And then when we heat this, it doesn't matter which part you heat. You can heat the brass or you can heat the iron. Now you come over here. Come over here and hold this. Now hold it carefully, huh? You can sit on the chair. Yeah, hit the center. Yeah, I will move you. You hold it there. Now, if the brass here expands more than iron, what will happen? Can you see what happened?
It bends.
Ah, it bends like that, right? Huh? And that is very visible. And this brass on this side and iron on this side are both heated. Brass expands more than iron. So when brass expands more than iron, you see that this becomes a curve. Huh? Now go back and sit in your original place. Now the curve is very obvious. Huh? The curve is so obvious. Can you see? The curve is so obvious. So this is called a bimetallic strip. Oh, curve so much, huh? That's curving a lot, right? That's curving a lot. Of course, it's very hot now. It's very hot now. Then if we put it here, when it cools back to room temperature, it will not be curved like that. It will not be curved like that. It will come back to be straight. Okay? So let's cool it here. And that has a application in a bimetallic strip here. So you see here? That application of bimetallic strip here, bimetallic strip. What does he say here? Can you read for us bimetallic strip?
Different metals expand at different rates. For example, brass expands more than iron for the same rise in temperature. Conversely, brass contracts more than iron for the same fall in temperature.
Okay, the converse is true. If I put this in liquid nitrogen or in the dry ice, then the iron will contract, no, the brass will contract more than iron. So if the brass contract more than iron, then it will be
Bend,
like what you see in C, right?
bend towards the brass.
Yeah. Right now, which one is brass?
The white one.
The white one, the shaded one is iron. So when it's heated, the bimetallic strip will then bend as in B. When it's cooled, the bimetallic strip will contract as in C. Is that clear? Does it make sense? Yeah. And therefore, you can see in figure 11.6. What can you see in 11.6? Figure 11.6. What can you see there? You have what we call a fire alarm, a thermostat actually. Well, in this case, it's a thermostat. The heating element, the zigzag portion, when heat goes through, then the oven becomes hot. When the oven becomes hot, the brass in figure A or figure 11.6 will expand more than iron, the shaded portion. Is that clear? And then the two contact there will separate. And when the two contact separates, then it will cut off the heat from figure B to figure A. Is that clear? Figure B is when you start, say, heating the oven. You start heating the oven, and when the oven becomes hot, when you set at a particular temperature, then the brass expands more than iron. The two black contact will separate and cut off the electricity in figure A. Is that clear?
Yeah.
And when it cuts off the electricity in figure A, then it will cool back again. And when it cools to a certain temperature, then the contact will come back to figure B to connect, and the electricity flows through the heating element again. And then it will continue to heat. So this is the function of what we call a thermostat. This thermostat is a manual thermostat. There are electronic thermostats which are very small, but this one is quite big in an oven. Okay? Yeah, so a bimetallic strip can be used as a thermostat, in a thermostat. And now you can see that this is almost straight now, right? It's almost straight. It's almost straight. Yeah, there you are. That's an application of the bimetallic strip. Thank you.